After completing the modules describing the process of operating an ETOPS flight, we are going to focus on a case study. The flight we are about to detail leaves Shannon Airport for New York. Our aircraft is an A330-200. The flight intended departure time is 13:00 Zulu time, with Airbus 101 call sign.
As a dispatcher, I have provided you with the following documents:
The ETOPS status of the operator and the aircraft.
NOTAMs, weather data, the CFP, and a plotting chart.
All these documents, with also FCOM and MEL extracts, are permanently available from the menu on the left of the screen. Let us start with the ETOPS status part of the checklist. Consider that the company, the flight crew and the route are approved up to ETOPS operation 180 minutes, with a diversion speed of 330 knots IAS. This leaves us with several routing possibilities, which implies to consider a different number of suitable en route alternates.
The maintenance department delivers the following release statement regarding our aircraft. Thanks to the available documentation, what are the consequences on our flight?
According to the MEL 49-10-01 Alpha, the only constraint is not to operate ETOPS flights beyond 180 minutes.
This has no impact on our operations, as we are approved up to 180 minutes maximum diversion time.
As the APU is inoperative, remember that APU master switch must remain off, and associated power sources are not available.
Let us continue to discover the content of our flight folder with NOTAMs. We consider in our case study that there is no NOTAM that has an impact on our operations.
In your opinion, what are the aspects on which we must be attentive? These items represent only the major points. It is of course important not to underestimate any message.
Now, we continue with the weather folder. It contains the TAF, METAR and SIGMET messages for departure, destination, alternates and en route airports. You also have the wind and temperature data for cruise and diversion flight level.
Temperature charts and icing forecast may also be provided.
In our case, we consider that there is no significant weather en route, and that icing is expected at diversion flight level.
Before looking at the selection of en route alternate airports, here is a preliminary overview of the CFP.
The CFP confirms a flight from Shannon to New York, with an ETD at 13:00 Zulu time.
ETOPS 120 minutes rules are taken into account.
The estimated flight time is 6 hours 42, with an initial cruise at flight level 380. Which means that given the taxi time, we expect an arrival at around 20:00 Zulu time.
Under ETOPS 120 minutes rules, we plan to choose 3 en route alternate airports. In the CFP, is also given the time window for the selected ERA airports. In your possession, start filling in the ERA form with the time window limits for the selected airports. Considering we plan our flight with 3 ERA airports, Shannon, Keflavik and Gander, we only need to report the data given by the CFP in the ERA form. Judging the weather data, select the expected runways in use for each supposed ERA airport. We are going to focus our computations on these runways, but in reality we would consider all runways. ETOPS dispatch minima are already pre-computed on the form. According to weather data and NOTAMs, are the approaches procedures in line with the requested criteria? As you can see, the conditions are in place for the selected airports to be considered as ERA airport. We can continue our preparation as planned. Our Shannon New York flight, in a transatlantic flight. It must respect the rules associated to this type of flight, such as NAT HLA, RVSM and so on. As we are focused on ETOPS topic, we consider that these related subjects are covered. As we have made a first approach of our flight preparation, we can start to report these items on our plotting chart. We have already mapped the routing, as it would be done at dispatch. Now, select the ETOPS ERA airports on the chart. We are going to use Shannon, Keflavik and Gander as ERA airports as planned. Focusing on Keflavik, select the appropriate threshold time circle. The CFP gives us a threshold distance of 420 nautical miles. On a meridian of the plotting chart, 1 degree of angle equals to 60 nautical miles. So, the corresponding threshold circle is the one with a radius of 7 degrees. Still concerning Keflavik Airport, select the appropriate maximum diversion time circle. The CFP gives us a maximum diversion distance of 850 nautical miles. By applying the same method as for the threshold time circle, choose the circle with a radius of 14 degrees 10 minutes. The same would be done for other ERA airports. Please, select now the ETOPS area of operation. This is the area contained within the maximum diversion time circles. As we see the main features of our flight taking shape, let us now go into more detail about the CFP. Cost index and, when available, performance factor are indicated on this CFP to update FMS settings. Indication of the average wind and temperature enable a gross comparison of the trip distance and air distance. A summary of the route enables a cross-check of the plotting chart. Further deep inside the CFP, we have coordinates for ETOPS specific waypoints. First, locate the EEP on the plotting chart. Make sure that it corresponds to the crossing of the threshold time circle from Shannon with your route. Then locate the EXP. You may also check that this corresponds to where the threshold time circle from Gander crosses the route. Continue by locating the ETP1 on the plotting chart. make sure you do not make any mistakes in reading the coordinates. Proceed in the same way for the other points. While going through the details of ETOPS data, can you select the critical fuel scenario? According to the CFP, the critical fuel scenario is the one engine inoperative diversion to Gander associated to depressurization. This is the scenario where the required fuel is the most important. Please, locate the critical point on the plotting chart. Do we need to carry on extra fuel for ETOPS purposes? No, as the CFP indicates no fuel deficit for the critical fuel scenario. The ETOPS fuel planning is covered by the standard fuel planning. The first page of the CFP sum up the fuel planning. All requirements are detailed, and we notice that no extra fuel is planned up to now for MELCDL items. In the same time, check that weight is within the limits, as for any non-ETOPS flight. What would our flight look like if ETOPS 180 minutes rules were used? In your opinion, what would be the main changes? With ETOPS 180 minutes rules, we can reduce the number of VRA airports to 2, Shannon and Gander. This means that we will only have one ETP left, and with one less airport to consider, the risk of weather disruption is dimmed. Also, a shorter routing can be chosen.